Hi and welcome to the exciting and fascinating world of helicopters. My name's Graham Gillies from Blue Tongue Helicopter Services. Today we're going to be doing a daily inspection on the bell47 type helicopter, the G model. We'll be doing a little bit of its history at the same time, telling you about the machine and all its little bits and pieces, as well as doing the inspection that the pilot would do on a daily basis to make sure the aircraft was airworthy before they take off on their first flight. The first part of the daily inspection, when you get to the aircraft, one of the requirements is to make sure that the maintenance release and the aircraft's birth certificate or its flight manual is with the aircraft. It has its own, is a problem with the stabiliser bar with resonance and cracking. We have an AD on the tail rotor blades to check for corrosion or any cracking in the blades. A 50 hourly inspection. WD the blades in this environment here is very salty, and we need to make sure that the blades are clean and salt free and no corrosions occurring on them at any time at all. And at the bottom we have greasy aircraft every 8 hours. The cheapest thing you can put into a helicopter is petrol, grease and oil, so we make sure that it has plenty of that. I'm not going to sign this at the moment because I haven't done the daily inspection, but I'll just place it back in the flight manual now that I know that it's here. And as a commercial pilot I can sign it, as a private pilot I can sign it once I'm licensed, or an engineer can sign it on our behalf before we go flying each day. And we'll just leave it here on the seat and we'll come back to that after we've done the daily inspection. We're going to start doing the daily inspection from the front of the aircraft. What we like you to do is to become uniform in the way that you approach the things that you do around aircraft, the way that you start them, the way that you run them up, the way that you do your daily inspections, as we're going to do now. And if you get a regime going and you use that same technique on all types of aircraft, then the chances are you won't miss anything, leave anything out, and look like a bit of a dill at times. So what we're going to do is start at the front of the aircraft and work our way right around the entire aircraft, then up on top, and then back down here when it's finished. If everything's okay, we'll sign the maintenance release and off we go. We're going to start the daily inspection at the front of the aircraft. We're going to look initially at all the things that are hanging down there under the front and the bubble condition and the glass condition to make sure that everything's okay there. Then we're going to work our way right around the aircraft. Initially what we want to find out is that there are no cracks or any damage to the bubble itself, and it's nice and clean. We always need really good visibility when we're going flying, and these machines, these bubble helicopters, are the most phenomenal vision helicopters there are. They're a joy to fly, they're great to look out of, and in helicopter flying you really need that vision to be able to fly the machine to its optimum. You're not crowded in, you've got plenty of space and everything's pretty nice. So we're going to look down here. We can see the outside of the console in there. We can see that the battery's attached and properly attached in there. We can see the drain pipe from the battery. We can see the bicarbonate of soda, which is there in case the battery should overflow, and because the battery's inside the cabin we need to dissipate those gases. Down here we've got the pitot tube, and we want to make sure that it's clear. We usually cover that in the evenings to make sure wasps or something don't form a home in it, or we get water in it when we're flying in rain. Make sure that it's clean. We've got a rotating beacon at the front. We make sure that it's secure and no corrosion or weeping there. We've got the outside air temperature gauge. We've got the transponder antenna, 2 VHF antennas on this machine. And we can also check the inside antenna connections and the pedals from this side of the aircraft. It's quite available to us to see that everything's in good condition. Okay, once we've had a look in here, we're going to move around to the right-hand side of the aircraft. And when we talk about right and left, it's as we're sitting in the pilot's seat. If it's on our right-hand side, the thing with these aircraft is the engine's been taken from this position and rotated and put around. So now the right magneto on an aircraft engine is now the left-hand magneto on a helicopter engine. So we have to be very sure what we're talking about when we talk to engineers. We're going to move around now to the right-hand side of the helicopter, and we're going to look at some of the features that are important to us here when we're doing our inspection. We've got to look at the skids. These aircraft do a lot of auto rotations. We have to look at the skid tubes here to make sure that there's no cracking around the bases here on the weld marks. We have to check the tungsten skid shoes under here to make sure they're not cracked or broken. We have to check the tubing around here to make sure that the bolts aren't loose and there's nothing fretting or wearing unduly. And what we can do is, to make sure that the tube's okay, we look through the tube, and we have to be able to see daylight. That one's okay. If there's no daylight through the tubes, when we look through them, they have to be either rolled over or they have to be replaced. They can only be rolled once. They can't be rolled more than once. So we look around here for the cracking down here as well. Okay, then we move up here to the tank region of the aircraft. To make sure that the tank's secure on the aircraft, we're going to check the mounting brackets just here for any cracking or any movement. We're going to check this bracket in here. There's two brackets in here. We're going to come back now to the Lord mount bolt, and we're going to check for any cracking coming off this particular mount. And then we're going to come back to the back of the tank here and just check this rear mount here to make sure that everything's secure. We look for any fretting on the bolt heads by any, if we can see any aluminium dust or any black sort of pasty looking things, it could mean that the bolt's moving in the hole and that it needs attention, that there may be some movement there and that we may get a cracked bracket. And that's the last thing we need with a heavy thing like this tank sitting up on top of it. Okay, we're coming down here to the oil cooler now. We've got to make sure that there's no oil leaks out of the input or any of the output pipes for the oil cooler. Air that's being pumped in to this shroud here that's going through the fins on the cylinders is also being pumped out through this cooler. It's a very nice place to stand on a very cold winter's morning to keep your hands warm while you're waiting for the cattle people to show up, because it gets quite warm here. It's very good too. The hottest cylinder on the engine's actually here, the number 2 cylinder. It has the cylinder head temperature probe on it. We check the rocker hats to make sure that there's no leakage and no oil running down the sides here. This is the return tubes that takes the oil back into the sump of the engine. Down here we have a starter motor. There we have the magneto. And underneath here we have the engine tachometer that gives us our revolutions for the engine. We have all our spark plug leads from one magneto coming up here to our cylinders. And on the back side we have a set of leads going into the second set of spark plugs in at the back of the engine. We check the exhaust pipes here for any leakage around the exhaust pipe seals, and we can check the inlet manifold for any leakage if we're looking for any discoloration like a blue tinge or a green tinge that would allow us to think that fuel was leaking out from that spot. We've got the cylinder head temperature probe that's inside number 2 cylinder. Down the bottom here we have the scavenge pump for the dry sump engine. This is a dry sump engine. It was a turbocharged engine in its day. It's a 435 cubic inch Lycoming. With the turbo, we've actually removed the turbocharger, but we still have the scavenge pump dry sump. The oil filters in here, and we have the oil temperature probe in the bottom here. Moving up from this part of the engine, we have the throttle box and the mechanical linkage. The generator, it runs off a pad on the transmission and supplies us with our 28 volt power that we need to run this aircraft system's electrical system. Moving back along the engine here, we have the oil reservoir. This holds the extra oil we need to run the engine. There's about 7 litres or 7 quarts, very similar, those measurements in this tank here. We check it before each flight to make sure that it's clean and the levels are up. We don't want to put too much oil in there, because if we overfill it as we're flying along, we'll pump that oil out and we'll think we're using oil, but in actual fact we'll be wasting it, because the engine likes to have a certain amount of oil in it, and if you put any more in it, it'll just blow it to waste. We don't want to do that. We check the exhaust system here for security. This actually moves, this concertina section, sits into the muffler here, and we're looking for any cracking on the muffler, any blowback where we might have done any damage from any backfiring. The safety straps that hold it on, the straps that hold it on properly to the mainframe, the bolt systems, etc., etc. Up on top here we have the short shaft of the engine from the transmission to the long shaft that drives the tail rotor. Because the engine's free to move inside the cage, we have a movable short shaft here to take up any slack as the engine moves backwards and forwards as we increase or decrease rotor RPM, or the disc tilts and moves the engine in its mountings. So that's free to move. We want to make sure it doesn't go clack, clack, clack when we move it, because that would mean there wouldn't be enough grease inside these boots. So we would put grease in there to make sure that there was movement, but no damage was being done to the splines on the short shaft itself. Okay, now we're going to move back along the tail boom. As we go along the tail boom, we're going to check any of these bearings here for excessive movement. These ones are in pretty good condition. As we go back, and we're also going to check these cables here. Here we have the sync elevator cables, and down here we have the tail rotor control cables that control the pitch on the tail rotor blades. We make sure that these connectors are properly wired. These all are. Once you look at them, you tend to look at them all the time and you notice whether or not things are amiss. Very rare to see something like this not wired properly. Moving back along the tail boom now, I come up to the synchronised elevator. I'm going to check this elevator here for any movement on its pivot points. This is free to pivot. It's attached to the cyclic by these two cables here, and when I push the cyclic forward, the sync elevator will come back, raising the tail in the air and aiding me in the manoeuvring of the aircraft along that, through that pitching axis. Checking the spring on the rear here to make sure that it's all okay. The vertical fin for security, corrosion, all the bolts. Come back along to the rear short shaft where it goes to the extension tube, and I'm going to check this universal joint here for any movement laterally in both directions on the universal joint itself, and the entire shaft for any movement on the bearing. There's a set of bearings here, a set of bearings here, and we come back up here to the tail rotor gearbox. I'm now going to check the tail rotor blades and the pitch change links for any movement. First of all, untie the main rotor blades. I'll pull the blades away from the frame and take the tie down off and give them a little bit of a shove. Be sure not to stand in here when you do that. You might get decked by the tail rotor as it moves. I'm going to roll this up and put it into the boot. Coming back to the tail rotor blade, I'm going to check the pitch change links. When I check these rose joints or ball joints, I check them laterally for any movement this way to find out whether or not they're moving badly or not, both ends. Some of these do have a little bit of movement in them. You find that even if you put a new one on, it will move a little bit straight away, but it tends not to get any worse than that. And another one of the engineer's adages is just keep an eye on it. You can take the tail rotor blades and check them for their rotational, make sure there's not excessive movement inside the yoke here. We can take the cable and check the tail rotor blades for movement, and you can see here that it's moving correctly. I'm going to check the tail rotor blade now for any damage to the leading edge or any of the skins on the inside and the outside of the skin. And I just gently push the blade forward to bring the other blade around. Here comes the other blade around to me now. I'm going to check this leading edge of the blade for any damage. You can pick up a twig, you can pick up a little rock. These blades form little eddies on the ground if you're in dusty conditions, and they can bring up dust that abrades the leading edge. They're spinning so fast it's like little tiny shots of lead or whatever hitting on the leading edge of the blade, and I've seen them open up and become very thin tissue paper wide. You can't put protective strips on them, because if you do and one comes off, the blade will be severely out of balance and could cause you some pretty serious difficulties if one part of any blade tape on the tail rotor blade came off. It's not a very good idea at all. Moving around to this side of the tail rotor now, we've got the right angle gearbox with the shaft driven up here, the shaft going through there, and you can see that the barrel here that's driven by the cables by your feet rotate the cables and change the pitch on the blades. There needs to be oil in here. This tail rotor gearbox gets quite hot. I can put oil in here through the top if I like, and if I'm out in the bush and I happen to have low oil, I don't have to use the Talus 46, which is a normal oil. I can put engine oil in it as a stopgap to get home. It's not a dangerous practice. When I get home, I can drop the oil out and put some proper gearbox oil in. But just remember that it definitely needs oil in it, and we want to be able to sight it in here. Don't overfill it. If you overfill it, you won't be able to see if there's any oil in there or not. And if you go flying like that, you'll never know whether or not the gearbox has oil in it. You can guess, but guessing's not good enough. We're going to move back down here now to these pulleys. Wherever the cables go through pulleys, we're going to get wear and tear. And with grease and oils coming from the aircraft freely, it can get onto the cables, get into these pulleys, and then can operate as a grinding device. It can actually abrade the cables away. Normally it'll do it from the inside of the cable out, so you might not know it's very broken until the actual break itself. Moving back down the cables now, down the end of the extension tube off the tail boom, we come to where the cables pass through this bottom pulley here. I've actually had a cable snap here while I was out working mustering cattle up in the Northern Territory, and I had to fly home about 40 miles with no control of the tail rotor because the cable had snapped. Quite a different kind of an experience, I might add. So we check them pretty regularly. And the vertical fin here, we're checking again for any corrosion on this side of the aircraft. Back onto the horizontal stabilizer here, or the sink elevator as it's called. And we're checking it for any movement on this side on its bearing here. Just double checking as we walk back down the tail boom. Check the boot here for security. We've got a first aid kit in here. Always make sure we carry a first aid kit and a spare ELT. The exhaust pipe on this side for security and the safety strap. The exhaust pipe itself, the concertina section. I'm just going to check the sink elevator and the tail rotor cables down here. There's two sets of pulleys. There's a lot of grease and fuel and what have you that drips down from the engine on occasion, so it can make the cables and the pulleys very dirty. So we must make sure they're all okay down there. These ones are in pretty good condition. They're okay. Very expensive these are, but you need them these days. We've got to keep the noise down a bit. When we're mustering cattle, of course, we just have open pipes. Makes lots and lots of noise and it's all good fun. But around in this type of environment, around cities and what have you, you have to keep the noise to a minimum. So we put these very expensive mufflers on. These ones are around about $3,500 each to have made and installed. Coming across here to the fuel cutoff. And this is the mainframe fuel filter. I have a drain on that. I'm going to check these shortly. This is the fuel tap. The fuel drains down through here, and I put a tap at the bottom and check the contents for any impurities. We'll just leave them for the time being. I just want to come back here around to this side of the engine. Here we have the heat exchanger for the carburetor heat system. Stainless steel around the exhaust pipe. I open up a little gate down here with a cable inside the aircraft, and it allows hot air to pass into the air cleaner and into the air box and through the carburetor to melt any ice if I'm in icing conditions. This pipe here is a drain for this scupper. Any fuel that overflows when I'm filling the aircraft will drain down this tube. This tube here is a drain, so I can check the fuel for water after every refuel. Again, I'm going to check the rocker hats on this side. I'm going to check for any oil leaks. One of the reasons we have white engines in our helicopters, they look a little bit sterile, but you can see every oil leak and you can keep your aircraft very, very clean because of it. And you can see a problem as it occurs and you can fix it. And we don't have any ongoing problems. We've had the good fortune in this company to not have a day down through unscheduled maintenance in the last 11 years. Touch wood or metal or whatever, but that's the case. Okay, again, we check the shrouds here to make sure all the clips are in because cooling is critical in these machines. Here we have the hydraulic reservoir, which I'm going to undo. Checking it for its level. In 24 years of flying Bell helicopters, I've never had to put oil in a hydraulic reservoir. Touch wood again. I'm now going to check out one of the ADs of the aircraft on the hydraulic servos in under the back of the engine here. I've got lateral servos, collective servo, and a longitudinal servo for the hydraulic control of the main rotor head, and therefore the disc when it's spinning. And one of the inspections is to make sure that these little screws at the bottom here on the pilot valve can rotate. And they all seem to be okay, and they're all rotating freely. I'll check the rod ends and the connections to make sure there's no excessive wear, and I'm going to check the fan belts for tension. The fan belts are drive the fan from the fan drive that comes out of the transmission. It's probably the most expensive single part in a helicopter, $11,500 US for one small quill that drives the fan. But the cooling in is critical. We have the other magneto for the engine on this side. And underneath the engine here we have the hydraulic pump, and we also have a yellow cap in here where you can set the engine up for timing when you want to time it, and if you are game enough you can actually put a crank handle in there and crank the engine over if you have a flat battery, but I wouldn't like to be you if it backfired. Here we have our 28 volt outlet for power so that we can plug power in and have ground power to start the engine if we have a flat battery. And we have a filter under here for the hydraulic system, and we're checking out the main frame for cracking, and back up to this fuel tank we're checking this fuel tank out for any cracking, the Lord mount, the front brackets of the mount as we had on the other side, and we're checking it out as well. Now that we've checked out this side of the aircraft and all the little components we have down here, we're going to climb up and look at the top end, the transmission and the rotor components. So we're going to have to climb up onto the main frame, and being an old bloke is a bit tiring, I'm going to use the rotor head to give me a bit of a hand, the rotor system. So I'll just give it a bit of a shove, and as the stabiliser bar comes round I'm going to hang on to it and let it give me a bit of a pull up onto the top of the head. Make sure you only stand on the marked parts up here and don't stand on the short shaft, it becomes very expansive. Okay, everybody seems to put their foot down here onto the fuel thing. So I'm going to start down the bottom and work my way up to the top. Starting down the bottom I'm going to check the pitch change links on the lateral cyclic and the 4.5 cyclic and the collective. I'm going to come up to the top part now to the scissor arms. They're always free to move a little bit here. Keep them well greased and they should be okay. The bottom of the control rods, we call these here, they come up the mast and go through this damper frame, which we're going to put our thumb and forefinger against the mast and the frame itself, and we're going to move the stab bar up and down to see if there's any movement against the mast, which there isn't. If there is, we can tighten these, but if we tighten them too much they will break. Come up to the stabiliser bar now. This is part of our AD check here. These bars are known to crack on the shoulder, so we check out the bar for cracking. We can give the bar a up and down and you can hear it hissing. These are the dampers here that are controlling the stabiliser bar to make it nice and smooth to allow feedback. We go now to these walking beams from the control rods to the pitch change links. We check the pitch change links for excessive movement. On this side they go to this pitch horn which is attached at 90 degrees to the front of the main rotor blade. This entire main rotor blade system is attached to the yoke, and I can actually move those blades slightly on those bars, but I'm just checking them for excessive movement. The yoke itself is free to move on these pillow blocks against this gimbal ring, and although the blades are free to teeter, they're also free to rock backwards and forwards. This is underslinging the head, and it allows for hunting or dragging motion of the rotor blades because there's no drag hinges here. They've got drag braces that prevent the blades from moving fore and aft. On the top I've got these counterweight bolts that aid me when I'm raising and lowering the collective with the hydraulic system, and I have the rabbit ears on top that are droop stops that allow much more movement of the blade when the stop is out, which it is centrifugally, and as the blades slow down the spring builds the rabbit ear back up and allows for a dynamic stop so that it's not too dangerous when you're standing on the ground near the aircraft. Obviously one of the most important things in the helicopter is the condition of the main rotor blades, to make sure that they're clean and undamaged. I'm just going to check the laminations to make sure nothing's come adrift here. These are pretty new rotor blades, they're in very good condition. I'll check the trim tabs when I jump down, make sure that both blades are okay on the top, and when we get down on the ground we can have a look at them from underneath. On top of the last part on top of the mast that holds the whole thing in place, the whole rotor head in place, is this little nut here. This is called the Jesus nut, because they reckon if it comes off the last thing you'll say is Jesus, because you're going to be doing a little bit of vertical flying. So all in all, we look at everything here, we can see that there's a lot of grease pumped into here. There's grease nipples in the grips. The grips are free to rotate this way, which gives you the feathering motion of the blades on both sides. There's a drag brace on each side. They're attached by these pitch change links. I'm now going to spin the blade around and check the other side. It's quite a heavy system this. It's a high inertia rotor system, which makes for good flying. And now we can come around and check out this side. So we can check the rod ends on the pitch change links. We can check this size of the stabiliser bar. Now the stabiliser bar is free to move between 22 and 80 thou on this laterally across here. That allows the stabiliser bar to find its own centre. These are very heavy, these weights at the end here, and inside of them there's a stainless steel tube, a rod, I'm sorry, inside of these tubes is a stainless steel rod. If I bang the tube, the rod should rattle. That's because the stainless steel rod is slightly longer than the tube, and it's there to hold this in place should this crack. You would get excessive vibration in flight, but you would be able to manoeuvre to the ground hopefully and put the machine on the ground to get it repaired. Okay, so we go down on this side. I'm just going to pull this around a little bit. We can see that there's oil in both the dampers. We've checked them. We've checked this side. Grease nipples here. There's 54 grease nipples on this aircraft, and it's quite fun greasing it, as a matter of fact. While we're up here, we'll check the security of this scat tube. This is the air intake, and it goes down to the airbox and into the carburettor. We have a problem with these. If we don't put any sort of support in here, they do deteriorate and collapse, and they have been known to suck in to the point where the engine's coughed. And I tell you, a coughing engine will give you the biggest fright in the world. So be aware that these must be in very good condition and keep a good eye on them. So I'm going, everything seems to be all okay up here, the gimbal, the yoke, the pillow blocks and everything else. So now I'm going to climb down to the bottom again and check out a couple of bits down here. Okay, here we have, this is a 600 series transmission. We can tell that because there's not a lot of ribbing on it, and the hydraulics are driven off the engine, not off the transmission. On the 900 series transmission, the hydraulics are driven directly off the tranny. We've got the rotor tachometer generator here. We've got a couple of oil tubes. This particular type of configuration with this engine transmission configuration is the only one where there's only one oil system. The engine oil system is the same oil as in the transmission. So we have to be very aware that if we have a transmission problem and we have any metal made in the transmission, that can be transferred back down into the oil system of the engine and can be very expensive. So we keep a very big eye on those kinds of things. Just walking out to the tip of the blade here, just reach up and grab it. It's always good to be a tall helicopter pilot. We want to look at the leading edge of the blade, make sure there's no dents. We do pick up debris. We don't have any blade tape on these blades. We fly around here in a pretty good environment, so you don't really need it. But we can pick up the odd twig or rock. They're in pretty good nick, and the bottom of the blade's in very good condition. Check the trim tab for security and any delamination. Come around here and look around along the trailing edge of the blade. If there's going to be any corrosion, it's going to happen right along the trailing edge along here. And we do notice in this environment that we do get condensation forming salt crystals underneath the blades if we leave the machine parked for too long. I'll just give that a shove and wait for the other blade to come around. Okay, we've got the other blade. Just check the leading edge and the tip plate. Make sure the screws are in. As we did with the other blade, we're going to check the trim tab for delamination or any damage. There's a very important part of the blade. They keep the blades in track for the fine tuning. After you've done the pitch change links and got the blades in balance, these are pretty good rotor blades. Well, there's still one very important thing we have to do before we go flying. It's the pilot's responsibility before the first flight of the day and after every refuel to check the fuel for contamination. So that's what we're going to do right now. I just need to get the fuel bottle out of the pocket here. I'll do the right tank first and take a sample. That side's okay. Now we'll go to the other side and the mainframe filter. Tank number 2. Take a small sample. Don't want to take too much. It's $1 a litre. Gets a bit exy if you throw it away if it's dirty. This side's okay. Now I'm going to check the mainframe filter. Need to get down here and turn the tap on up here at the mainframe and take a sample from down below here. On some of these aircraft there is a drain on the carburettor. We don't have one on this particular model. There's only the 3 drains and the fuel is perfect. So I'm going to take this away and put it in an environmentally friendly place, probably back in the petrol tank. There's nothing wrong with this fuel, and there's nothing wrong with putting it back in the tank, not at the prices we pay. There's probably about a minute of flight there. If it was dirty, obviously I'd throw it away and check the tanks again to make sure there was no contamination. All in all, this aircraft's in very good condition. It's very old. It was built in 1966. It was originally CSX, a turbocharged helicopter owned by Crowley's Air Services in Papua New Guinea. It came down to Australia and later on as a rebuild from an accident and was designated as Hotel Bravo Yankee. It's been cattle mustering, it's been spraying, it's been flying training, it's been a film platform, it's been in plenty of films. It's quite a versatile machine. It's a beautiful machine and super reliable. It's never let us down, and we hope it has a great history into the future. Okay, well I've done my daily. Everything's okay. I've checked my fuel, I've filled it up, I've checked the oil, everything's all okay. Maintenance release is right. I'm going flying. I'm going to have a good time. It's a beautiful day. I'm going to head down the coast and have a look at all the white pointers as I go. See you later.